Pandas. They're not furry critters. It's a Python module that deals with tabular data structures, and the lab walkthrough starts right now. Okay, I'm out here in the lab, and in this very first cell, let's just talk about what's happening here. We are importing the Pandas module and the NumPy module, and Pandas stands for panel data, and it is a way to deal with tabular data in Pandas. NumPy is a array support library, so it's a way to do a numerical analysis on lists of data. We probably won't use NumPy anywhere in this lab, but typically when you import Pandas, you import NumPy as well. One other thing to note is that I could just import Pandas, but I'm importing Pandas as PD, which is aliasing the module name Pandas so that I don't have to keep typing in the word Pandas. For example, when I say PD read CSV, I no longer have to type in pandas.readcsv. This is a convention that is used throughout the Pandas community, and I wanted to follow along with it here. Okay, that's number one. Number two, you'll see I'm importing a warnings and then changing something around. What happens in Python, there's a logging feature, and you might want to disable certain warnings that may show up so that the warnings don't appear down here in your output. And so that's all this is doing, is ignoring the filter type warnings that may occur with Pandas. Okay. The last thing I'll mention is how Pandas works. So Pandas is super convenient. If you think back to the web API, right? We had some resource on the internet and we queried it, and then magically we got back a Python data structure that was a list of dictionary. Pandas works similar. You go get a resource on the internet. Usually the resource on the internet is a file in a file format, but could also be a web page, and it can also be an API, believe it or not. And then what Pandas will do is read in that file format. In this case, the file format is in what's called CSV format. And if you wanted to see what this file looks like, you could always just copy this and look at it. And so you'll see that the file has data in it. They're separated by commas. So you might say to yourself, well, I don't want to parse this data. That seems like it would be not a lot of fun to use a for loop and do a with open and, you know, read in these things line by line. That's no fun. So that's what read CSV does, is it does all that heavy lifting for you. And what you get back is a data structure that is in a panel's data. Okay, is what is called a data frame. And let me just run this code now. And what you get back is this tabular data structure. So whereas before we would get a list of dictionary and then we'd have to for loop over it or whatever, now you could just display the tabular data itself this way. And if you look at the source data here, this says sample. Let me get the first few with head. Okay, and it says Mr. Owen Harris. And there's Mr. Owen Harris right there. And then there's this person, Miss Lania. Miss Lania. Okay. So we are getting that data with Pandas. And again, that's what Pandas does. It is a convenience library. And the Pandas module has a function called readCSV, which will read in this, which is in comma separated values format, and it reads it in and it puts it into a table. And this table in Pandas is called a data frame. And one of the methods on the data frame is head, and that says give me the first 10 items in the data frame. I can use tail to get the last 10, or maybe I say tail 3 and get the last 3. If I do sample, I get a random sample. So this will give me random 3. And if you look over here, there's this column. This is called the index. The index column refers to, you know, the natural sequence of items that were as they were read from this file. So the first one is index 0. So I'll go back. Let's do head again. And that first one is index 0. So every data frame has an index. The index is generated automatically by the read CSV function. Okay, this is a method function that's part of Pandas. And then this is a method function that's part of data frames. So if you want to learn about all these functions, you have to go to the Pandas website, or you can go and do what we usually do, which you can do a dir, right? If I said dir PD, I'll get all the stuff I can do with Pandas. And you'll see in here there's read CSV. You can read an Excel file. You can read a feather file. I don't know what that is, but you can learn about it. You could read an FWF file. You could read an HTML website. You can read JSON format. So that read JSON format is useful when we call a web API and it returns JSON. And we want to take that output of that JSON and we want to convert it into a data frame. We want to display it in a table like this. So super handy. Pandas data frames will save you a lot of coding, but you have to understand how they work, which is why we have the lab. Okay. So enough of that. That was a good intro. Just one more time. I know you got it in large group, but it's always good to hear it more than once. So now we go through and do some of these other examples, which this one says, take one column out of the data frame. Let me go back to sample here. 10. It says, take one column out of the data frame, survived, and give me a sample. Now you'll notice you didn't get a juicy data frame back. You get back this thing. This is called a series, okay? And a series is nothing more than a single column out of the data frame, okay? It is not a data frame itself. If I wanted to retrieve a data frame, I would actually have to put double brackets around this, like that. And then it treats this series as a list, and then because it's a list, it thinks it's a data frame, and then you get back the data frame. Okay, but we don't want that. We just want the series. So that's the difference between a series and a data frame. All right, so this gives us value counts. And then this allows us to normalize the value counts to find out that 61% of the passengers did not survive, and 38% of the passengers did survive. And you might be saying, well, are you pulling these out of the ether, Mike? Again, no. You have to bring up the docs or do dir of that, and it'll tell you all the functions that are available. And once you get past the internal functions, there's a lot of them. You'll see that there's add prefix, align, apply, count. There's also in here, if we go down far enough, there's min, max, right? Min, max, average. There's value counts down here. Okay, and if I want to know how to use value counts, I could put value counts here and use help, and that'll tell me how to use value counts, right? With an S, Mike. And then in here, I can see it has a normalized false. And if true, then the object is returned will become a relative frequencies. Okay, so normalizing gives you a percentage of the whole versus a count. Okay, and that's how I knew how to do that with normalize equals true down here. Right? These are things that we learned way back in Unit 5, and they just are coming back up and rearing their head. So now we can do 1.1. I know it's a long way to 1.1, but the backstory, I think, helps rather than just throwing the answer and you typing in the answer. Write a Pandas expression to display counts of males and female passengers using the sex variable. Okay, so that must be one of the columns. So let's do this. Let's do, what's the name of our data frame? Passengers? Columns. So one of the columns here is sex. See that? All right, so now I can do this. And I get back males and females. See that? All 890 passengers or 891 passengers. I want to show you something. If I put in something in here that is not a column, you know, I get a key error. Why? Because by definition, a data frame is a list of dictionary. And right now, the columns are dictionary keys. So getting a key error on a data frame means you're asking for a column that doesn't exist. That's why you need to do columns like this. And let's take that sex. And then I can get the value counts. You know, this is not very useful. I need to know how many males and females. I could for loop over this. Right? I could say, you know, for row in passenger sex, right? And then keep a male count and a female count. And then in here I could say if row value, you know, is male. I could do that. The beauty of Pandas is that it allows you to express a lot of things where you would normally need to use a for loop without using a for loop. It uses like a declarative syntax, and it's really handy. It avoids a lot of code where you would have for loop within for loop within for loop within for loop within for loop just to analyze the data. You can do it in a much more expressive way. So now let's solve the problem. Passengers, sex, value counts. Series has no object value count. When you get something like this, it means that this isn't the right function. Right? That's not the right function. I know it's value counts. I just wanted to show you what the errors look like. There we go. So there are 577 male, 314 females. All right. That is 1.1. Okay. 1.2 is pretty easy to figure out, right? 1.2 is the same value counts. But we want to express them as a percentage, right? So I want to say normalize true to see them as a percentage. I did it again with the value counts there. So 64% of the passengers were male, 35% were female. Okay, that's 1.2. I know this really isn't a, U code, but I want to discuss what is happening in this cell here, because it is incredibly powerful and extremely useful and doesn't look very intuitive. So let's talk about what we did up here and what we did up here, right? And up here. So this one here, right, in our 1.1 code, we got a value counts by sex, and now the series index is male and female. And then down here, what we're doing is we're taking all the passengers and we're filtering those passengers so that there's only survivors. That is, where the survived column equals 1. And then we're just getting a count of the IDs of the passengers. To just show you what's happening here is if I show you this, sample 10, every single person in this list, in this data frame, has survived. Why? Because this line up here says take the passengers data frame and remove only the rows where the survived value equals 1. So all the ones that are 0, I don't see anymore because this one's only survivors. All right. So then down here, we get a value counts of survivors by sex, which also has the same indexes, female and male. Because they have a common index, we can build a data frame out of these outputs. And here's how it works. So I make one variable, which is the value counts of all passengers. Then I make another variable, which is the value counts of all survivors by sex. Then I make my own data frame, and I have one key called all passengers, and the value for that is the series of all passengers. And then I have one key called survivors, and the value of that is all the survivors. Let me comment out line 5. So that gives me a data frame that says females, 314, 233 were survivors. Males, 577, 109 were survivors. Then what I do in line 5 is I engineer a column in that data frame called sex survival rate, which is the ratio of male-female survivors to male-female passengers. And then I get 74% of all females survived, and 19% of all males survived. Okay, so I'm building my own data frame out of these series. Normally, to do this, it would require a couple of for loops and an if, and a couple of some advanced logic and an additional list that you're building. And so you can see that Pandas, while you have to know what you're doing, once you know what you're doing, it's incredibly easy to harness the power of Pandas to express large quantities of data in extremely simple ways. All right, let's set up 1.3 down here. Rather than just me throwing the code in here, let's do the setup. So up here, we are adding a column to passengers called age cat. You can see right now there is no column called that. There's no age cat in here. So when I do this first cell, it adds that column, and I'll show you that. I'm just going to run this first cell. And then let's take a look up here. And so now there's an age cat column. See that right there? And if I just show you like a sample from there, all the age cat columns say nan, which means not a number. It means I don't have a value for you. Okay? And that's because we're going to engineer a value in there. All right. So then the next thing we're going to do is we're going to say, excuse me, if the passenger's age is under 18, or it's 18 or under, then the age category is going to be child. If the passenger's age category is bigger than 18, then we're going to label that person an adult. So we're going to replace all these nans with either child or adult, and it's perfect overlap because we split it right on 18. But I need to use two statements to do this. The first one fills in the children, the second one fills in the adults. Okay, then when I look at the sample now, some are labeled adult, some are labeled children, and if there's no age, see that? If there's no age, if I don't have data on their age, I can't label them adult or children. Makes sense, right? These people we want to ignore in our counts because we don't want to count people that don't have an age. Okay. With that out of the way, we can get value counts by age category, right? And we have 575 adults, 139 children. If you add that up, it does not add up to the 931 people that are on the manifest, and that's because some people we don't have ages for. Like Adolphe Salfield, we don't have any age for this person, therefore we cannot classify them as an adult or a child. This, by the way, is called feature engineering, what we're doing over here. We're adding a column to our data frame so that we can do an analysis on that column, but we're basing this column on another column. Let's take a look at that. 80% of the passengers are adults and 20% are child. So now we can take a look at the survivor rates. And if you look, of the adults, 220 survive. Of the child, 70 survived. You might say, wow, not a lot of children survive. But you got to remember, they don't make up a large portion of the overall population of people on the Titanic. So what we need to do is apply the same kind of logic that we did way up here, where we build this. We want to see all passengers, age category survival rate. So that's what we're going to build below. All right. So we have age category all series, age category survivor series. Let's take a look at those, by the way. Right? 575 adult, 139 children, age category survivor series. 220 adult, 70 children. So I want to build a data frame that has adult, child, this, that, and then this divided by that, and this divided by that. So let's start it out. Let's call this age data frame. And we're going to build our, we're not going to load a data frame. We're going to build one out of what we have. So we use PD data frame to build it. And then we want to give it a dictionary. And the key is going to be, this one's going to be called all ages. And that's going to be age cat all series. And then we're going to do survived ages. Or I guess we could just say all. And then survived. And then this one's going to be age cat survivor series. Let's start there. Oh, I got to show the data frame, right? There. So 575 adult, 139 children, 220 adults survived, 70 children survived. Now we want to do exactly what we did up here in our output and show that ratio, that rate, survival rate. So let's engineer that column. Age DF survival rate. And that's going to be the age DF survived divided by the age DF all. And that's going to give us that survival rate. And I screwed something up. I probably spelled survived or all wrong. Let's see. All looks right. Survived is wrong. See, I know immediately. I got a key error. You get a key error, it means you're asking for a column that is not there. Okay, because again, Pandas by definition is pretty much a list of dictionary. It's actually a dictionary of series, right? Where the dictionary key is the column name and the series is the data. And it would help if I used the right data frame name. There. So there's a good, there's some good analysis, right? So of the adults, 38% survived. Of the children, half of them survived. So it's good to be a child on the Titanic. It's also good to be a female on the Titanic. Your survival rate was much higher. All right, that is 1.3. Okay, it seems like women and children first is the rule on the Titanic, or it was. Let's take a look at, does passenger class matter? Did the first class passengers survive more than the second or third class passengers? What you're going to see is that the first class passengers had a 62.9 survival rate. Let's figure out how to engineer that. You're going to follow the same process we did before. So let me take you through it. I'm not even going to scroll up. We're going to do it all from scratch here because at this point, again, you want to try to get uncomfortable with your coding. You don't want to do a lot of copying and pasting. Getting uncomfortable is how you learn. So we start out with passengers, right? Columns. Excuse me. And we have a P class. So let's take a look at that. P class. There it is. And there's first, second, and third class. Okay. And I can do a value counts of that. There we go. There's a breakdown by passenger class. Okay. Now, I need a breakdown of passenger class by those that survived, right? So this is just all P class. All P class series. So now I need to build myself a survived P class series. Okay, that's what I need to do next. How do I do it? Let's start from scratch. Passengers. I only want the passengers that survived. Okay, only the passengers that survived. Good. I want to get from that just the P class. And now I want the value counts of that. See how I'm building this out? The only way you can do it is to build it out like this. Run it, run it, run it, run it, run it, run it. Got it. That's the Pandas way. It's so anti-programming. It's so anti what we've been doing. That's just the realities, if you will, of how data analysis, programming via data analysis works. And that is why the notebook environment is so highly sought after as a programming environment for data analysis. Because if you're using an IDE, you'd have to run your code, right? But we're really not running code, we're exploring with code. So having a notebook where you can just keep running like this is so useful. You know, let me go back and do it again. Build this. Aha. Build this. Aha. Build this. Aha. Right? Got what I need. Aha. What do I do with it now? Put it in this variable. Aha. Now I got to continue with my data analysis. I need to put both of these in a data frame. So I'm going to construct a data frame called class, pclass, df, and it's going to be a PD data frame. And we're going to have a dictionary. And one of my keys is going to be all. And that is going to be this one. And then another key is going to be survived. And that's going to be this one. Okay. Now I probably want to look at what this data frame looks like. I want to see it. There we go. So of all passengers, 216 of them were first-class passengers and 136 survived. Of the third-class passengers, there were 491 of them and 119 of them survived. So you can already see the survival rate of first-class passengers is pretty damn high. Let's give hard evidence of that. We need to engineer a column. Let's call it ratio, because I'm out of ideas at this point. And that's going to be the P-class survived over the P-class, P-class df. Over all. And let's see what we get now for our data frame. There we go. So there it is. 62.9% of all first-class passengers survived the Titanic. Sucks to be a second or third-class passenger, I guess. That's 1.4. Okay, we are here in 1.5, and it is time to put it all together and show that a whopping 91% of all passengers that were children, female, first-class passengers survived on the Titanic. And that's who you wanted to be. And while 38% of any random passenger survived, your best odds of survival were to be a female child first-class ticket holder. So let's prove that. The numbers are already here. Let's write the code that verifies the numbers. So we start with passengers again. And what we need to do is we need to engineer a column out of class, sex, and age category. So I want the class. I want that to be 3. Oh, not 3, 1. passenger class 1. In addition to that, take that, and I want the sex to be female. And in addition to that, I want the passenger's age cat to be a child. Okay? And there's not many of them. Not many of them. Okay? And you can see one didn't survive, and all the others did. All right. So this is our source data set. This is what we call, let's call it first female child. First female child. Okay? Now we need to get the survivors out of that. That would be first female child survivors. And that's going to be pretty much the same thing. Like that. So let's see what we got here. There's the ones that survived. There's all of them. There's one extra. Okay. Now we want to build out our data frame like we did before. So I'm going to call this FFC DF PD data frame. In this case, I'll call this all, and then we'll do FFC, and then survive. And that's going to be FFCS. Oop. And I got to do FFC DF, and then I got a value error here. Okay. Oh, I forgot to do my value counts, right? Value counts. And then this should be value counts. Value counts. Okay. And I spelled survived wrong again. And I still spelled survived wrong. Or it's, oh, you know what? I can't do it this way because it's not a data frame anymore. I need to take this FFC. And I need to make, this is FFC DF, do it that way. And then FFC is going to be FFC DF value counts. Am I doing this right? I don't know. Sometimes I think I'm on the right path and then I'm not. So let me tap the brakes here for a minute. Let me comment these out. This is a good lesson in think before you code. Okay. Yeah, I can't do a value count. Well, it's value counts, Mike. I can't. I do a value counts and I get all of this, right? What I really want to do is follow the instructions. It says filter the passenger frame by the above criteria, normalize the value counts of survived, right? So I actually took this too far, as usual, by just not following the directions. I have my FFC data frame, right? And then I just want to do this. I want to say FFC DF survived. And then I want to do value counts. Normalize true. If I read the instructions, I would be good to go. See, there we go. There's my 90% and 9%. And if you want to see what's happening there, you can take a look. All right, and that's 1.5 right there. All right, let's do a bonus because we're getting close to that point where you want to learn how to build more project-y type things. So what I want to do is I want to add IPython interact to this and make these all be interactive variables that you can select. Okay, I'm going to do that. And then we're going to get survivor rates. So oh, man. There we go. I'm going to import just interact. I'm not going to use interact manual. Okay, now what am I going to do here? I am going to do this. I am going to have a list called classes, and that's going to be 1, 2, 3. I'm going to have another list called sexes, and that's going to be female, male. Ladies first, always. And then I'm going to have one called category, age cats. And that's going to be adult. Child. Then I'm going to feed those into my interact. I'm going to do interact. Classes, classes, let's call it P class, classes, sex, sexes, and age cat, age cats. So I'm sending in those lists, and then I'm going to make my function, my input function. Let's call it analyze. And then I'm going to and then the analyze takes P class, sex, and age cat. And then I want to build a data frame like this, but I don't want to use P class 1. I want to use whatever this P class was input or selected. I want to use that P class. And this is a little unruly, so I'm going to try and break it up onto lines. I wonder if this is going to work. And then this sex is going to be sex. Whatever you pick, and then this one is going to be whatever you pick. Okay. Now, when you're using an interact, and then this is going to be the let's see if this works. I'm going to just break it up onto multiple lines. When you're using an interact, you can't just do this. You have to use the display function, which is why I imported it. I think it's display like this. So let's do this. Let's put this in a variable. Let's call ratio. And then let's display ratio. And now we got a little interactive Titanic analyzer. If I put a colon at the end of line 8, that would be smart. And I got, so okay, it doesn't like my indents. Doesn't like that. It says, dude, you can't do that. There we go. I tried. It doesn't work. Okay. IPython, I spelled that wrong. Is it IPython like this? There we go. With a little p. All right, what am I doing wrong here? Okay, it helps to have, IPython little display. Okay, so here we go. So passenger class, second class, females, 91% survived, males. Okay, adult, child, third class female. Now these numbers, you look at these, you're like, what? What does that mean, right? So, you know, that's something that needs a little expressing, right? But the 1 means that they survive. So, third class female children, 51% survive. Just to show you, first class male adults, 62% survived. Third class male adults, only 13% survived. 86 did not, right? So let's just figure out how to extract out just the survival rate, and we'll print that in there instead of this ugly thing that doesn't make a lot of sense. All right, so what did I do there? Oh boy. Oh man. All right, there we go. I found it. So I say ratio, and then I want just the 1, right? So I want to grab that index there, and that's survival rate. And then I can say display. How about a nice fat F string? Let's display it in HTML using, I don't know, heading 3. And then say survival rate. And then that was going to be like that. There. Let's see how that goes. And I got a mistake because I forgot a parenthesis probably. 1, 2. Yeah, I forgot a parenthesis. There. So 97 survival rate. Female adult. Female child. 90. Okay. That's the one that we know. Let's do it again. Passenger class, third class, male, child 21%, adult 13%. Okay, that seems to be working. This is ugly. You can also format that, right? We can do this. Dot 2F. Maybe not. Yeah, it would help to do it right. Boy, I am off my game today. There. Throw in a little. There. So female adult, female child, first class male, second class male, second class female. Oh, 100% of the children second class survive. Adult, third class female, 42%. Third class child, 51%. Male, child, 22%. Adult, 13%. Cool. So that is a good example of, you know, building a data product, if you will, from a data set using pandas. And you can see I'm not showing any pandas here, but look at the actual code that it took to do this, right? And if you think about it, I know I'm going a little long here. This is, you know, these are imports. This is boilerplate to just give you drop downs. That's all it is, right? This is just to build the interact. This is the meat of the program. What this program does is it loops over passengers, filtering out the selected passenger class and the selected sex and the selected age category. Then it keeps a running count of that and gives me only the survivors from that running count. So, I mean, if you think about the code that you would normally have to write to do these lines of code, this is a really 3-line of code program right here. It becomes a lot easier to do in Pandas. And that's my sell job for you with Pandas. Okay, everybody, that was a lab walkthrough. Thank you for watching. Goodbye.